Okay guys, so what we have here is a PowerPoint and it looks at the combination of those index laws we've been looking at over the last couple of PowerPoints. Okay, so we have a couple of examples here and we might be a little bit intimidated. Up until now, hopefully we've kind of been a little bit comfortable with all of these problems. Simply applying one rule at a time, it's been quite nice, but this is where the complexity can start to kick up a gear, and we do need to start combining our laws. So what I'm going to show you is how I tend to approach these problems. There's no real hard and fast order that you need to apply the rules. It's not like you apply index law 1 and then 2 and then 3. So there are a couple of different ways that you can approach this, which I really like because I get to see some of you guys putting together some really interesting ways to getting the answer. There is one answer though, okay? So no matter what approach you take to simplifying the problem, we should all end up with the same thing if you've applied the rules correctly. So we'll start with the first one. The first one's a nice, easy warm-up because we are looking at what law would we apply. So first things first, we need to double check that we do have the same bases, okay? We can't do anything if those bases are different. The laws don't apply. Now, we have 4 and 4, so our laws do apply, and we have a multiplication. So our multiplication tells us that we are going to be using the addition rule. So 2 plus minus 3, okay? And then I just need to simplify, evaluate that power. I get 4 to 2, take away 3, I get 4 to the negative 1. Okay? So that's kind of the thought process that I like to use when I solve these sorts of problems. Okay, so let's go to the second one here. This one's a little bit harder. As I said, there's a number of operations occurring at any one time. So we do need to be a little bit careful and think logically about how we proceed. So I need to be careful, okay? I have some 3s here and I also have some 2s as my bases. So we won't be able to combine everything. Keep that in mind. I really like to address my brackets first, just out of habit from my bomb dash days. So I'm going to go ahead and I'm going to apply my power laws up here to my brackets first and then have a look at applying them. So I only do it one step at a time. So as I said, this 3 to the power of 2, well, there's no other 3 numbers with a base of 3, so it's just going to kind of hang out there. But it is multiplying by 2. Okay, so as I said, I had 2 to the power of 2, all to the power of minus 2. So I have a power raised to another power, which is my multiplicative law. I'm going to multiply those 2. I only want to do one step at a time, so I'm going to leave this here and I'm going to come back to it on the next step. And I'm going to go 3 to the power of 2 times, so I'm going to evaluate these powers here. 2 times minus 2, I get 2, well that's minus 4. Okay, so I should, write down this one. Maybe you might skip this step in the future, and I'll show you why. Because now what I'm going to do is I can see, well, I have a base of 2 here on my denominator and a base of 2 on my numerator. Another way to think about that, okay, is dividing by 2 to the power of 3. Okay, both the exact same expression. So what I can do is use my second index law, which is my subtraction law, which tells me that I have 2 minus 4. So divide, I can subtract the powers, take away 3, and write my final answer. Negative 4, take away 3, I should get minus 7. Okay, that's the process. Very careful, step by step, making sure we include all the necessary procedures. I show what laws I'm using. I'm showing all my working. There's no doubts that I've got those right. Great, this one here is very similar. Okay, there's a couple of laws to be applied, and so we do need to be careful. I'm just going to tidy up my numerator first. I like to do my numerators first, get everything in order. So I have x to the power of 5 times x to the power of 8. They both have bases of x, so I can apply my law. I have 5 plus 8 divided by x, 3. Okay, so same here, I have divide, so I'm going to subtract that. So if I tidy this up, I have 13, subtract my power of 3, I have x to the power of 10. Okay, so what we have, guys, is a couple of we-dos. You know the drill. If you could pause the video, come back in a minute or two after you've had a turn and see how you went. See you in a minute. Okay, so the important thing with some of these questions, guys, right here on this slide in particular, is we need to keep track of our different variables, our different letters. So for this problem, we have m's, which I've underlined, and n's, which I've overlined. Now we can only combine, we can only apply our index laws, okay, to values with the same bases. So we can put our m's and our m's together and our n's and n's together. It's a little bit like collecting like terms if you think about it. So what I can do is it's all multiplication, so I can use my addition rule, which tells me I can add my powers. Okay, it is m times n, so I do still have the times between the letters. This is n to the power of 3 times n to the power of 3, so I add those powers together. Final step, I should definitely simplify. I get m to the 6 times n to the 6. Similarly, guys, this second example here, okay, we have two variables with x's and y's, so we are going to be applying those rules specifically to those pairs. As well, we have the 12 and 24 out the front as well, which we'll need to simplify. Now, I like simplifying my numbers first. I'm pretty comfortable with numbers. We've been doing numbers for a little while. So 24 divided by 12 is simply 2. And then we have x cubed divided by x squared, y to the 6th divided by y to the 4. So if we have divisions, guys, it means that we are looking at our subtraction laws. So I have x to the 3 take 2, y to the 6 take 4. Of course, I want to tidy that up. 3 take 2 is 1, y 6 take 4 is 2. And completely up to you guys, obviously x to the power of 1 here, it's a little bit over the top to write 1 because with or without it, so 2x y squared is exactly the same as 2x to the 1 y 2. So it's good practice getting rid of that 1 if you leave it there, however you're not hurting anyone. Same story over here, guys. We have some numbers out the front, we have some x's which we'll put with our other x's, and some y's that we'll put with our other y's. Let's multiply all those numbers together. So we have 9 times 3 first. As I said, numbers are nice and easy. 9 times 3 is 27. X's, so it's all multiplied. So I have x squared plus, so there's no power, which means it's just a 1. If it was 0, it wouldn't be there at all. So I know that if I have x written, it must be a 1, unless it has a number higher or something else written. Times y, so again, there's no power over there on our y, so it must be to the power of 1. Plus, because it's times, power of 1, because there's no power there, plus 1. Tidying that up, I get 27x cubed y squared. Hopefully your answers look something similar to that. If that's not the case, guys, have a bit of a look through, go back over the video and have another crack yourselves. Last one here, guys, we have some U-dos. So what we're going to do, leave you to it, come back in a minute or two, and we'll go through these answers again. Rightio, let's go really quickly. Divisions, okay, so you can think about this whole front section being divided by this whole end section, or this being the numerator and the second one being the denominator, okay? Numbers first, so 9 divided by 9 is 1, x to the 4, okay? Divided by, so I'm going to take away x to the 1, y squared divided by, so I'm going to take y to the 1 as well. So I don't need a times by 1, that's a bit of a waste of time. I can get rid of that, y to the 1, and again, I can get rid of that y to the 1 because it's a bit of a waste of time as well. This one here, so again, you can think about it as being this whole front section divided by this whole end section. We get 36 divided by 18, which is 2. X's with X's, so it's 7, take away 5, take away because of the division obviously. Y to the 9, take away 7. Tidy that up, 2x squared y squared. Lastly, okay, got to be real careful with this one, okay? This squared is going to apply to everything. So it is going to be 8 squared, but also x2 all squared. Now we know what that means. It is the product rule, the multiplicative rule. 64x to the 4. Guys, there is a worksheet there for you to practice these combinations, to practice being on the lookout for where to apply what rule and when. And that, arguably, is one of the trickiest skills, okay? So it's important to get that practice in. It's not just a matter of remembering the rule or applying the rule, but learning those problem-solving skills. Can I apply the correct rule at the correct time? Okay, and only practice will help you do that. So please make sure that you have a go at that. If you have any questions, please talk to your teachers, and I'll see you next